Hello YouTube and welcome back to my crazy electronics project. Today is PCBWay delivery day. Whenever it's PCBWay delivery day, it's always a good day because it means that I've got more stuff that I can build and put together. So this little circuit board adds an extra 7 ICs on top of 2 existing ICs that are on the video board. And this board adds extra functionality for a configurable background color if all 4 of the layers that are being drawn are transparent. The current operation for the video board is that the last layer is not transparent, which means that color 0 from each of the 16 color palette banks is not transparent. It means that the last layer currently could need multiple palette updates to create what's called a raster bar effect or a color bar effect, which is basically the graduated sky effect that you can see in the Shadow of the Beast demo. That's the best example that I've got so far. Now this board will make it so that I can configure the video layer to have a background color from a background color register. There's an extra latch which is going to go here, an 8-bit latch, which remembers the current index into the 256 total palette entries that I have in this design. And as I said, if all 4 layers of all 4 of those pixels are transparent, then it can optionally read the palette entry for the background. Now this means that I need to then just update one palette entry to create a graduated sky effect or a filled sky effect, for example, or color bar effect, instead of updating multiple palette entries, depending on the palette entries that are used for particular tiles or characters or sprites and so on and so forth. So I'm going to first update the video board to replace the 2 ICs that would normally sit in this position underneath on the underlying video board. I'm going to replace those with sockets. Then I'm going to test that those sockets are still working with the original 2 latches, which will then end up here. So actually we are completely replacing the functionality of this latch with the logic here, which is the configurable background register. So there's going to be a couple of tests for a transparent pixel, which is what these ICs will actually do. And then there is some and then there is some selection logic here, which basically either chooses the original functionality or the new functionality based on the logical test for the transparency check going on here. So that's all that we're going to do, is that we're going to update the video board, check that it still works with the sockets, and populate this, add some headers underneath, which will then plug into the sockets on the video board, and then plug this in and then test the new code and the new functionality. So let's get into it. This is going to be a long video, by the way. There's a lot of desoldering, and well, there's quite a bit of desoldering to do, and then there's a lot more soldering to do afterwards. I mean, it's not that much, it's only 6 extra ICs and a couple of extra sockets, but you know, I haven't soldered for quite some time now, and I thought I might as well do it because this is a nice small board. So this board actually looks very nice and neat and very well put together. As always, from PCBWay, I'm very, very happy, as always, with their great product offerings. I can heartily recommend them. They're very, very fast. The turnaround for delivering these bare boards was actually extremely quick. These boards actually almost arrived before the rest of the components from my preferred component supplier, which is Mouser in this case. So yes, always very happy with PCBWay, so thank you very much, PCBWay. So let's get into it. Let's go to the video board and then start working on that. So here we are back again. I'm going to desolder these two first, put in these two leaf sockets here, or white sockets here, and then I'm going to put back the two ICs, which are two identical ICs. And I'm going to desolder these first and then try the board after populating everything back again. I'm going to desolder this one first, then this one second. So this one, there is a long one, two shorter ones, and then a long one on top. This is where I measure often. You see, it's the bottom resistor ladder. Long one, two short ones, and then one raised above. So the resistor ladder, long one, this is actually a RAM. Two short ones and then upwards here. These two are the latches for the output pixels which go through the resistor ladders. So long, two short, tall one. Bottom one, bottom resistor ladder, long, two short, and then the tall one. So it's that one. There. On this corner here. That I am desoldering. These two rows here and here. Not the two here, because that's for the decoupling capacitor. And then here. Now, this is my trusty Hakko desoldering iron. The way this works is great. You just put it on and then suck, and then as long as everything's fine, pin is actually free at the underside of the hole. I can feel that the pin has recessed into the hole. In other words, it's not in there anymore, so I think it's just a matter of, yeah. Let's just double check what we're seeing on the other side. The wire is still in the hole. So, not last resort, but the next level of thing that we're going to do is first of all, I'm going to try desoldering braid. Not likely to work on its own. You know, when I said it wasn't likely to work on its own, I was wrong. It seems to have worked really, really well. Okay, well that's a good trick. See, good trick to learn is use desoldering braid, which is a very, 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 very good conductor of heat. I don't need the flux now. So the desoldering braid, because it's a very, very, very good conductor of heat, seems to have spread the heat of the desoldering gun. Wow. Over the pad much better, and then the desoldering gun sucked through the desoldering braid, and actually I can see the blob of solder on the end of the desoldering braid. So let's just snip off the used part of the desoldering braid. because once desoldering braid has got solder on it, of course it's not going to suck up any soldering. You don't want, you know, dirty desoldering braid. So now, brilliant. Now I can put in this, hopefully it'll just slot straight in. Ta-da! Okay, now at this point, this is where I pack up the desoldering gun, and then I put in, I unpack the soldering gun. I don't have enough desk space, unfortunately, to have both at the same time. Not usually, anyway. I was just considering that. But there we go. See how I'm touching the metal part? All right. So hello again. So now I've packed up the desoldering gun. Now ready to start soldering these. So I'm just gonna tape them into their sockets, or rather tape the sockets into their positions on the board. You see, I generally tape things down that need to stay in their proper positions when I'm turning the board over, obviously, for obvious reasons. You don't want them to fall out. You don't want them to partially come out and the pins are only half in the holes, for example. You want the pins to be right there. You want the pins to obviously be in the right place at the right level into the holes. So I'm going to be soldering that one, and I'm going to be soldering that one. These two. There we go. I can see where I'm meant to be soldering because they're all empty, right? Yeah. Very obviously different. Soldering iron. Solder. Magnifying glass. That seems to be all fine. And then just making sure that there are no solder bridges where there shouldn't be solder bridges, and that all of the holes have solder, which it looks like they do. And then here. A visual inspection always generally saves a lot of heartache. Okay. All of that seems fine. So now what I'm going to do is that I'm going to do what I said that I'm going to do about an hour or two ago now. And I am going to repopulate now those wipe sockets. I'm going to repopulate them now with the original components, and I'm just going to make sure that the board works in the same way that it was working before, without the daughter board, because I need to figure out what I'm going to do now about the headers for the daughter board. So I have my little chip leg reformer, just to make sure everything is good. Actually, let's put the top back on the flux. Let's take out that thing there. Let's put the flux back in the bag so I don't forget where it is. And let's put the flux syringe inside the soldering box. There we go. Right, anyway, so IC with its straight legs, IC, straight legs. Now these wipe sockets tend to be a lot more forgiving anyway, in terms of leg placement compared to the turned pin sockets. Generally, as long as everything is lined up and everything's fine, then it should be fine, and it should just go in. Of course it's not going in. Sometimes they do need a bit of pressure. Now I do have extra of these ICs. I actually found a whole bunch of them. And I have a whole bunch of ICs in this box as well for populating the rest of the board, so you know, everything should be fine. So if I do break one of the legs, it should be alright. Let's get the other one. Let's make sure its legs are at least sensible. Make sure it's up the right way. That one should be fine. Bing, 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 bing. That one's a bit wonky. Make sure that side is in. Make sure that side is in. Nice, even pressure across the whole thing. One side sometimes pops in before the other one. That's not a problem generally. As long as you can push in both sides, then it's okay. There we are. Okay, now let's test this board again. So there is the video board plugged in now with those, I don't think you can really see, but the ICs are now in sockets. They're kind of like over there, the higher ones. Anyway, so it's generating a video picture, which is always a good sign. The Commodore 64 is on. Let's press A to go back to the Shadow of the Beast demo, and everything looks okay. Good. I can still hear audio from my earbuds. Yep. I don't have the speakers plugged in. So anyway, that's all working still. So I know that I haven't fried the video board. Yay! So now I'm going to figure out how I can make the daughter board properly so that it will go into those wiped sockets. So here we have the video board with the daughter board installed. The headers go into the sockets underneath here and then up through to here. The little fly lead goes to the memory data selector, decoder selector here, which lets the latch for the background register to read its correct value, which is this one here, I think, if I remember correctly. This one is the output pixel latch, which feeds back into here, which replaces this functionality here. This basically gets split into two, the input side and the output side. And then this latch is the background register, I'm pretty sure. So yeah, now all that's left now is to test this board to see if it actually works. So welcome back. I actually discovered that on the board I needed a bodge wire, so I needed to add this trace here. This trace connects the logic for detecting whether or not I want to enable or disable the background color to the latch which contains the overall video enable disable register. So I've just uploaded the new code build which uses this flag. So the new code build is here. It uses this flag called enable disable enable display use background or BG color background color, and it sets that into the enable display register. Okay, so and then it uses this function here, video enable display. So by passing that flag in, it will enable the logic on the board to use the latch for the background color. All of that code has been added to the Commodore 64, so let's start that off and magic. So this is the new code using the much more efficient palette update the background color register. So when all of the layers are transparent, it only uses the background color register once here. So this palette entry, which is going to be palette 0, I think it is, will just update the RGB values with the APU as it goes down the screen. So that is a lot more efficient than updating 2 or 3 or sometimes probably even 4 palette entries as it goes down the screen. I press fire, go on to the next section of the demo, which is the game. So I can move right, I can move left, I can jump up and down. There we go, so that all works really well. It's nice to have such powerful extra functionality added by a relatively small number of integrated circuits onto a daughter board as well. So the hack is actually not too much of a hack. This change for the background color enable disable register has already been added to the main video schematic as well. So if I get the video board remade at some particular point in time, then that change will automatically come through. And of course the change has also been added to the emulator side of things. So if I run the emulated code, we can see that the emulated game is the same as the video hardware game. Now let's just prove that the code is working as we expect. So if I comment out, basically disable the background color register, and then I run the emulated version, what we'll see is that the tiles won't update correctly, because the tiles don't know that they have to be transparent, and so the tiles, which are the last layer, will be showing the palette entries for each color index for the tile that's being used. So this is why we get all of this purple stuff, or the purple stuff in the background. We can see here that this is tile 0, but this is probably tile color index 1 or 2 or 3 or whatever. And we see here as well is that the sprites, because this part of the screen here, the sprites are actually the rearmost layer because they are behind the tiles, which are the clouds. So the sprites use color 0 here, but color 1 or 2, or so on and so forth. So that's why we're seeing purple. So if I run the same code on the hardware, so if I try and run that code, here we go. Okay, purple in the background, the same kind of like pattern, because the tiles and the sprites aren't set to be transparent for the last background color layer now, so it does the same thing as we would normally expect. So let's reset that again. Let's quit the emulated code. Let's re-enable the background color register. We run that code. This is just basically validating that the hardware is behaving now the same as the emulation after all of this botch fixing and everything. So we do this, and then we run that on there, and then the Commodore 64 will come back to life. There we go. Cool. That's much better. So I'm really happy with that. So thank you very much for watching these crazy electronics hacking project videos. If you like what you see, then please do consider liking and or subscribing to this channel. Have a great day or evening wherever you are. Thank you.